Okay, hi everyone. My name is Asaf. I run business development for enterprise and cloud at Mellanox. I'm going to talk a little bit about the play that networks have in the Ceph world and a little bit about the early experiences that we've had with customers. So who said hardware is boring? So who are we, Mellanox? We're a leading provider of end-to-end high-performance server storage connectivity. That consists of basically everything you need to connect data points in the endpoints in the data center, starting from network adapter cards, through transceivers and cables, through switches, everything on technologies of both Ethernet and InfiniBands from 10 gigabit per second to 56 gigabit per second. We own all the intellectual property in our products, so we design our own ASICs, our own hardware, our own software. We complement the hardware with layers of software that allow applications to make the most out of that hardware. I'll talk more about that as it relates to Ceph. I'm not going to go into too many specifics about the products themselves, but people can reach out to me later to talk about it. So we've been around since '99. We're about 1,500 people today, $500 million revenue. We started in the HPC world and then moved on to other places that had similar needs like storage, cloud, Web 2, etc. In the world that we're in today, you have sort of these next generation applications that are creating this humongous new volumes of data. They're running on top of these next generation platforms, which are your cloud, your software as a service, your Facebook. And at the end of the day, someone needs to bring in the next generation tractors also that will put in the pipes that are going to be able to carry this humongous amount of data, and that's where we come into play. So what's happening today in the storage world is very similar to what happened years ago in the HPC world. So we're moving from a concept of scale-up systems to scale-out systems, right? And in reality, to sustain the growth that we have in data, there's no other way to scale. If you want to be able to manage these huge amounts of data at normal cost points, you have to move to a different model, and Ceph is basically there, right? It's moving to a scale-out architecture. In the HPC world, in the early 2000s, this happened with the move from mainframes to grid computing or cluster computing. And back then, they already realized that in order to scale the performance linearly and be able to get as much performance as every additional CPU can give you, you need to reduce as much as possible the impact of that network in between. Because in reality, you've added something in between that's connecting all these endpoints, but you want to still get 10x performance when you put in 10 boxes. So in order to have that seamless interconnect, really what that means is it has to be lossless. It has to be extremely high bandwidth, meaning at least matching what you have on the PCI bus. It has to be extremely low latency. And you have to offload the CPU as much as possible. So if your CPU is now spinning cycles on this communication, that's not good. That's less computation that you want to do. So those are the four key elements in this seamless interconnect, which is what's really going to enable you to scale the performance of distributed systems linearly. So when you look at Ceph specifically, a lot of the key attributes that Ceph brings as a storage system really rely on this high-performance network. And I'll mainly talk about two of these aspects. The first one is everything that relates to availability. So someone mentioned in a previous discussion that Ceph doesn't bring you eventual consistency or eventual availability. You want it to be fully available and consistent at every moment. And for that, you need your replication, your rebalancing, your synchronization, all these functions that are in a different path than the data path, you need them to happen in zero time and with zero interruption. And you also probably want to separate them from your client network. You don't want client misbehavior to impact the core of sustaining your whole cluster, and you also don't want to create unnecessary congestion for the client. So one thing that happens in most medium to larger Ceph deployments is the separation of the networks to what's called the cluster network on the back, which runs all your replication, your recovery, etc. All the OSD communication, and the public network, which is more client-facing and in many cases can be more tolerant, can have some of the flavors of the legacy network. In some cases, that will also have high-performance requirements, and we'll look at that in a minute. The other angle is the amount of data required. So the back-end network typically requires or moves at least 2 times the data of the front-end network. Depending on the number of replications we're using for data, you can see that what a traditional 10 gig Ethernet network can maybe sustain on the front, you need at least 2-3 times that capacity on the back. And you also want that traffic to move as fast as possible because you want your replications to be seamless, etc. So you need that back-end network really and primarily to be very high performance and isolated from day one. So these are the areas in which high-performance networks are really critical for Ceph. So a little bit about what some of these deployments look like. So I couldn't mention any names here, but this is a deployment we're currently working on for an 8.5 petabyte Ceph deployment. And this is actually a web environment where there's a lot of ingress data. So it's not your typical enterprise client network. They actually needed very high performance all the way up to the client network. So what they did, the back-end network was a no-brainer, going with 40 gig Ethernet connectivity here. But then on the public network, really there were 2 things that were driving the need for high performance there as well. Number one, they didn't want to cause congestion on the front end of these OSD servers. So what they did is they used 10 gig up to the client with 40 gig uplinks here and an aggregation layer of 40 gig Ethernet here so that each of these OSD servers gets multiple 40 gig links and can have this many-to-one connectivity without creating congestion. But the second and maybe more important thing is that they wanted to use SSDs across the board. And once you start using SSDs, you blow that 10 gig Ethernet pipe away instantly. So that's the other reason they really needed to front end this with 40 gig. So the overall cost actually of this thing, and this is the total Ceph cluster, not including the client machines, but all the Ceph servers and networking, including adapters, cable switches, storage, SSDs, everything came out at retail price. So this is not what the customer actually paid, but the analysis, the retail price was only about $350 per terabyte. And the customer probably paid much less. So this is an example of what a deployment looks like. This is the higher end of deployments, but it really stresses all those different points in the network. So typically where we get involved these days, so people who are just starting to play with Ceph for the first time are usually like, well, let me first figure this out, the manageability, the usability, all these moving pieces. I'm not really, I don't have the bandwidth to talk about performance now, right? I need to understand how this works, bring it up, work on all these components, you know, don't talk to us. Those are usually not the people we talk to. We usually come in on round 2. They figured that part out. Now they got it up and running, and it's choking. Why? I've used my legacy 1 gig, 10 gig connectivity, whatever our regular data center people were doing, and that's where we usually come in. So over the activities that we've been doing, we've actually put together a white paper that details a full deployment of high-performance network environment. I'll talk a little bit what it looks like, and then there's the link here, and you can come to me later if you want more information, but we've really detailed there everything required to set this up, and it's really very simple and straightforward. But what's detailed in the white paper is really, like we said, a back-end network, which is 40 gig Ethernet, completely. Configuration accordingly of all the OSD monitoring, MDS nodes to fit that, possible use of SSDs for journal or more than that. And then we've documented actually 2 different use cases. One, which will be more a vanilla enterprise use case of a 10 gig Ethernet public network up here with 10 gig to the servers, and another use case which is more high-end with 40 gig Ethernet going all the way to the server. And we've documented also the benchmarks involved and the different performance criteria. And you can see there, obviously, very large difference in the throughput and also in the I/O per second. So depending on application characteristics, et cetera, one might be more important than the other, but definitely throughput, IOPS, and latency all get a big boost in this environment. So it's a good white paper to look at. And then for a while, we've been working on accelerating Hadoop. Even before Ceph came along or was in infancy, we were doing a lot of activities around Hadoop and what's the optimal network configuration for Hadoop. Because even though in Hadoop, you're bringing the compute to the data, so to speak, when you're working on very large data sets and you're doing the analytics part of the map reduce and you have all this shuffling of data, well, guess what? Some data actually has to be moved. So we've been working on that for a while, and then we realized some of the synergies and the challenges of coexisting Hadoop and Ceph that some people mentioned here before. And this is another research paper that we've done. It's not yet on the website. It'll be up, I believe, in a week or 2. But really what it shows is, first of all, easy replacement of HDFS with CephFS. So CephFS was used here and was able to give that unified experience for running both the rest of the storage or the organization and what might currently be a separate environment for Hadoop, but also actually perform much better. So we were also able to get on a 1 terabyte Terasort benchmark, which is typical analytic benchmark for Hadoop, we were able to get 20% better runtime. So it's there. There are obviously the areas to complete on the CephFS that people here have mentioned, but it's going to be very comprehensive and complement different areas of the workload. So that's Hadoop. So the other area where our solutions are unique, except for bandwidth and latency on the hardware, is how do you enable applications to make the most of that? So in the HPC world, the concept of RDMA is widely used. I'll talk about it a little bit because I'm not sure everyone's familiar. But basically, RDMA stands for Remote Direct Memory Access. It's the ability of applications to directly communicate with remote applications' memory space without involving the operating system. Once you involve the operating system to move your data, you're obviously starting to get into queuing, buffering, copying, interrupting, a lot of things that slow you down. And they not only slow the runtime, they burden the CPU, so you have a double impact here. With RDMA, communication is completely offloaded from the processor. So it goes from user space directly to the hardware and directly to user space on the other side. So the benefit is really double. A, there's no bottleneck, so you can completely fill the pipe and get the lowest latency. And apart from that, you're freeing up your CPU to do other things. And that's where really, when we go back to what we talked about, the scale-out impact of how you get that seamless interconnect, a lot of that ties back to RDMA and how do you minimize the impact on your CPU for communication. So when we saw Ceph and started following Ceph, we knew we had to get RDMA integrated there because it would be a perfect use case and it would really allow it to scale. And I'll talk a little bit about what's happened there. But those of you who know from the HPC world, in the early days when someone wanted to do RDMA, had to go learn something called InfiniBand verbs, very complicated programming model. And it was a big deterrent to people. In HPC, people used MPI, which was sort of a shared library that was very useful. But in enterprise applications, people didn't really want to go there. There was a lot of programming skills needed. So over the past couple of years, we've actually brought out an abstraction API called Accelio, which is completely open source. And it actually abstracts all the connection and memory management aspects of RDMA and gives an RPC-like API, so it's very easy to port applications to use this. The other area where it's unique is the ability to support multiple transports. So in the past, another reason people were afraid to go to RDMA is because they didn't want to have vendor lock-in. Well, what if we want to later go with a vendor that doesn't support RDMA? Our applications are going to be locked in. So one of the core foundations in Accelio is multiple transport support. So you can, once you integrate your application, you have the ability to use RDMA if your hardware supports it, and you have the ability to run over TCP/IP if it doesn't. So we work with a lot of large ISVs that use RDMA. So years ago, Oracle made that move, and back then they had to go through all the hard labor of the verbs, API, etc. But more recently, we've done it with other large ISVs that have used Accelio, and the time to production is about 10x less compared to what it took Oracle close to 5 years to bring really RDMA and Exadata and all those platforms to production. Today, it can take a similar ISV, 6 months. In terms of performance, using Accelio and RDMA, you can get more than 10 gigabyte per second on a single network adapter, and you can get latencies under 10 microseconds under significant load. So there's another session actually later that's going to talk about how RDMA is enabled. That's a session by Cohort FS. They're going to talk about the work they've done on enabling RDMA for Ceph. So I didn't want to talk too much about it and steal their show, but that's coming soon. And there's a lot of public information already about that, and it's been discussed in some of the forums. So basically, to summarize, the scalability and availability requirements for large environments of Ceph really have high requirements for high-performance network environments. You have end-to-end 40 and 56 gigabit per second networking available today with full CPU offloads. Very soon, also end-to-end 100 gigabit per second. And like I said, Cohort FS will talk more about the RDMA implementation, the performance results, the integration, and all that in the afternoon session. Thank you.